Okay, welcome to lecture videos for Chem 151. So the semester that I'm recording these, we've already covered this in class the first night, but I'm adding this in just so we have a record of this for potentially for use in the future, or in case somebody might have missed that first lecture. One of the issues that we want to focus on in chapter 1, in fact, the first couple issues are kind of mathematically related issues. I like to cover those first because they come to play in lab at an earlier juncture than some of the other issues in chapter 1. So I've separated chapter 1 into two different lecture note documents, one that deals with these mass issues, the other one that will deal with some of the other issues in chapter 1 and things like problem solving and density. So looking at numbers is how we want to start. And we really want to separate numbers into two different categories. Now, a number is usually going to be associated with a measurement that we make, although that's one of the distinctions we're looking at that is not always going to be the case. So there's two different types of numbers that we may encounter. There are exact numbers, and then there's measured numbers. And you can tell by the name, right? The measured number is something that's going to go along with a measurement that we make somehow when we're conducting an experiment. But the other distinction is helpful too. Exact numbers are just that. The value is exact. There's no uncertainty. A number is measured. That means there is some uncertainty or inexactness in that number. And what that uncertainty is describing or what it means is something we want to look at. So in terms of exact numbers, there's two ways excuse me, that a number could be classified as exact. One is if we can count the number of objects in that number. So if something is countable, it is exact, or it could be exact by the result of a definition. So we will see in some cases the definition of the units of time of seconds and minutes are related to each other, such that 1 minute is exactly equal to 60 seconds. And since that's the definition of both of those terms of measurement, we would call that an exact number. Now, every other number is measured, and any number that is measured is going to be at least partially defined by significant figures. And significant figures are going to give kind of a range of meanings to a particular number. It's going to describe essentially how well we know the precision of the measurement that was made. If we make a really good measurement, then that's going to have a different number of significant figures than a measurement that is maybe not so accurate. So when we look at a number, we need to think about significant figures, right? And additionally, when we're in the lab and we're recording a number, we need to consider how that measurement was made so that we know how to record the number the appropriate way. Now, some of these issues will become clearer as we go through some of the examples and I show kind of how different significant figures changes our understanding of the number. Okay, but the first thing we want to think about is how we can identify how many significant figures are in a number. So I have 4 rules here for significant figures. We'll go through them, and I'm going to make a note of how many significant figures are in each number here, right? That's something you're going to want to get used to evaluating whenever you see a number in a calculation. So the first rule, any non-zero number always counts as significant. So if we have a digit that isn't a zero, that is going to count as a significant figure in our number. So all of the numbers here, 2,734, that would be 4 significant figures. 392, that would be 3 significant figures. And 27, that would be 2 significant figures, right? Because there aren't any zeros, because all of those digits are non-zero, they would all count. Okay? That just leaves the zeros. So where a zero is will determine whether we'll have to consider it as a significant figure or maybe not a significant figure. Now, if a zero is trapped between non-zero numbers, that zero always counts as significant. So 102, that's 3 significant figures. 39,083,002, all of those digits would count as significant figures, so that would be 8 significant figures. Okay, that's fairly straightforward as well, 0 in the middle. If a 0 is at the beginning of a number, right, and when I say beginning, that's the left side of a number, and generally we're comparing the zeros to the non-zero digits. So zeros to the left of all the non-zero digits. Those zeros never count as significant figures, right? And if you look at the examples, the first one is kind of silly. 00312, that's 312. We normally wouldn't write 312 with two zeros in front of the 3 in the hundreds place. And there's a reason for that, because that doesn't add any information to our number. So that's a 3 significant figure number. Now, the second example, right, here's a case where we do need those zeros before the 4, before the non-zero digits. But those zeros are there to represent place. They're not there to represent precision of our measurement. So 0.0045, the only significant figures in that number are the 4 and the 5. That would be a 2 significant figure number, because all 3 of those zeros are to the left of the 4. Right? So they do not add significant figures to our number. 0.023003, right? A couple of these zeros are trapped, so they will count as significant figures, but a couple of these zeros are to the left, and they will not count. So this would be a 5 significant figure number. Okay. Now, where zeros start to take on maybe a little more complexity is when they're at the end of the number or to the right of the non-zero digits. So if zeros are at the end, to the right of a number, those zeros are significant if there's a decimal point present. They're insignificant or not significant if there isn't a decimal point present. Right? So what does this mean? 5,000, no decimal point. That would be a 1 significant figure way to write 5,000. Now, I want us to explore a little bit what exactly that means. So say we do a calculation, and based on the data, we need to round our answer to just one significant figure. Well, if we had the value 4,501, and we need to round to 1 significant figure, right? The only place we could keep a significant figure would be the furthest to the left. So I've got a 4 here, followed by a 5, and it's just a little bit above exactly 5 in that place. So that means I would round up. If I only have 1 significant figure, I would just have the 5 in the thousands place. So 4,501 would round up to 5,000. 5,499, if I'm rounding that to 1 significant figure, would round down to 5,000. So I can keep this 5, but then the first place that I can't keep is a 4, and that means I round down or I drop all the rest of the information. So saying 5,000 with 1 significant figure is really telling us the number is somewhere in between these two values. It's a little more than 4,500, but it's a little less than 5,500. So that's a pretty big spread. So this is not a particularly well-performed measurement, right, that we maybe would want to do in a laboratory. Now, what if we had the decimal here? 5,000 with the decimal. That decimal point changes those 3 zeros. All those zeros are now significant figures, and this would be a 4 significant figure way of writing the number 5,000. Well, what is this describing in terms of ranges for possible values? So again, say we make a measurement, but based on the components of the measurement, we've got to round to 4 significant figures. 4,999.51 would round up to 5,000 if we were rounding it to 4 significant figures, because we could keep a figure here, 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 here. We're dropping this 5. That means we'd round this one up, this one up, this one up, and add up to 5. So rounded to 4 significant figures, that would give us 5,000 with the decimal point. Also, rounding to 4 significant figures, 5,000.4, and it doesn't matter what comes after the 4. If that first digit is 4, this would round down to 5,000 with the decimal. So by putting in that decimal place, we've now specified a value for our measurement that's between 4,999.5 and 5,000.5. So by expressing that number with 4 significant figures, we're expressing a much smaller range of uncertainties in terms of the way that measurement was performed. Right? And we basically have kind of an unlimited ability to shrink that uncertainty, right? As long as that's what matches the measurement we made, we can add more zeros here. So there's a 6 significant figure way of writing the number of 5,000, and that would mean we've moved the uncertainty out even further. So 5,000.005, I'm just going to add a 1 there so it's not exactly halfway in between. If we're rounding to 6 significant figures, that would round down to 5,000.00. Sorry, I messed that one up. That should have been 4,999.9951, since I'm starting low instead of going high. That would round to 5,000 exactly. Above 5,000, it would be 5,000.004. That would round to 6 significant figures down to exactly 5,000. So again, what's happened is we've really shrunk the window that we're describing with this measurement. So there's a lot of power here and a great deal of information that's being expressed in just the simple idea of, do we add another 0 here, or do we add a decimal point or not? And that's what we need to try to do with our numbers when we're doing a calculation, is make sure that the number we write is really expressing how well we have measured that information that we're describing. And in terms of working in the lab, right, there's a useful idea here at the end, and this really only applies to rule number 4. So zeros to the right or at the end. Can you choose to write a 0, or do you have no choice of whether or not to write a 0? So the first 5,000 here, you can't take away those zeros without changing the value, right? If you take away those 3 zeros and just write 5, that's not the same as 5,000. So you don't have a choice. You have to put those zeros. And if you don't have a choice, those zeros are not significant. But you can choose to add a decimal, or you can choose to add zeros past the decimal. And when you're making that choice, you're doing it to express precision. You can choose to add a decimal. You can choose to add extra zeros. So if you do have the precision, you should add those extra zeros. Okay, now that we know a little bit about significant figures, we'll practice a little bit, then move on to some calculations. We'll do that in the next video.